I can't do that.
Your quarter test? Yes, it's next Monday. So guys, today we'll do 8-1. Really that was just to give everyone a chance to get the Unit 7 test taken. Then Thursday in class will be quarter review day. I should have your grades fully updated in SIS at that point, so you can make an educated choice on whether or not you're actually going to take the quarter test. And then next week, Monday is your quarter test. And you guys realize Friday next week you don't have school. End of the quarter, teacher work day. No, then you have a week, and then you have spring break.
But next Monday is the blood drive, and you guys should sign up for the
Sign up for blood drive.
So guys, you might want to think about if you are planning to take the quarter test and you are doing something with the blood drive, you might want to just think about all of your choices that day. Don't go, ooh, I'm going to donate blood during my quarter test so I can take it late. No. Come and talk to me about that decision. Right. For the blood, right? Yeah. And you should donate blood. Just think about it. If you know you're going to donate blood, take your test.
I'll probably not.
I don't want to donate.
Mr. Neely is watching, or I might come back. Probably help you.
Okay. Are you taking the quarter test? Do you need to take the quarter test?
I don't have all of it.
I would say probably not worth your time.
I'll find
It's a totally optional test. Like if you're... No, I agree. Yeah. Okay.
almost died. You took a chemo.
Okay, so were you well hydrated before you donated last night? And had you eaten?
I think I ate a lot.
Yeah.
But it's the last time I ordered the last time
Oh, yeah. I would make sure you eat plenty before you eat. Yes. I don't know today. Probably Ben. It's someone testing, so you can move them. Yeah, you can't see them all the way back there. Okay, so that was 3 minutes of nothing that has to do with anything. So, all right, guys. Did you jot down f of x and g of x? Yeah. You have it yet? Okay, hurry up. All right, you can jot down 1 and 2 also. And try to do 1 and 2. Yeah, you've seen this before. This is not factoring. I'll take attendance while you're trying.
Yeah, because she's doing like the circles and the arcs and all that stuff. And I actually had to like there's like I don't understand the psychology of that stuff. I'll do that next time.
For class, there's like the awkward like laying like this much for like chair.
Hey, wait, you're starting today with me?
That's just Fletcher style.
Unique, baby. Best store in the area, even though it's like slightly hazardous when you go to but it's good. The workers were like hazmat suits. Yeah. There's a lot of things going on. The people who work there are not allowed to speak to you. They're like,
How's the f of -1 and g of 2 going, guys?
oh wait, right. Are we doing just all of them?
Yes, do that. Yeah, I want to see if you guys remember these from Algebra 1 and Algebra 2. You substitute it in and you simplify, yes. I'll go through both of them here in a second, but yes.
This is not a calculator?
This is all non-calculator, guys.
Oh, that's unfortunate.
No. I am not asking you anything hard.
You get negative 313.
We'll see.
So what's your list?
I should know that off the top of my head and I forget. I have a weird one.
Can you be negative?
No, it's like- A negative. PEMDAS, parentheses, exponents, multiply, divide, add, subtract. Alright guys, let's go through them.
And so,
Alright guys, what'd you get for the first one? -5. Alright, everybody go with number 1. Okay? Obviously it'll get a little more complicated than that, but the general idea, you have the value, you plug it into the variable. You remember this? Yes? Okay, so the second one. So negative. This is not hard. What are you struggling with? 4 times 2 or 3 times?
oh, no, I just like,
Or was it 5 minus 8? Maybe that was the hard part. I don't know. Did we get negative 3 over 13? Yes? Easy? Okay. So you're just plugging stuff in. Alright, so now let's go ahead and plug in variables. Okay, so find f of a plus 1 and g of 3a. I think number 3 is where you're going to have the most issues.
sure.
Okay.
So you just do the same thing?
Same idea, but you'll have a's in your answer at the end.
Oh, yeah, that's cool. Are you? Yeah, it's almost like it was. So what might be
Nope, no factoring, just multiplying. Talk to each other, see if you agree with your answers. You guys don't like these because you feel like it's incomplete when you still have A's in it. Okay. You would. Yeah, you just feel like you're not quite done, but you are.
Yo. I don't know how I sign up.
You go at like.
Wait, is it all this week?
Yeah. Start it by Friday. See your parents sign it.
I got, you get like, oh, I found four. It's done as I get, that means I get plus one. That's yours, right? Would you for that?
So we were supposed to.
No, that is not factors.
But you're supposed to.
Multiply.
A plus 1
A plus 1 squared is in factored form. You're gonna spoil? Is that the word? The other X word? Alright, guys. You should have done 2a squared plus 8a plus 3. How many of you messed up right here and just said a plus 1 squared is a squared plus 1 and left out the 2a? Anybody do that?
Not me, I'm shot.
Not yet. Okay, just remember if it's a quantity squared, that's actually that quantity times itself. Okay, that's the mistake most people make. Or you forget, you know, to distribute your 4. Where this can get tricky is I could make this like -4, and then there's just a lot of places to mess up the signs. The general idea, guys, this is still just like algebra 1 stuff. Okay?
Oh, so this is fourth quarter.
This is 4th quarter.
It's done with school forever, guys.
So yes, the end of the year, guys, is going to go really quickly because we'll have quarter ends, spring break. Once we get to May, it's all the testing, and you have all the weird schedule where it seems like I don't see you for like 2 weeks, and then all of a sudden it's finally
Is that
exams.
all
Yes.
successful out of school?
You what?
I'll probably go see
Okay, that's good. Good to know. Maybe more. Not a lot. I'll teach you because we'll do like through the unit 10, and then it'll be quarter review, quarter test, final review, final exam. Like 2 weeks of testing, like reviewing and testing, so kind of things. Yeah. Oh, yes. What's up? Yes. Every quarter, yes. You have to have the celebration of learning, meaning you have to come, but like I will make that pleasant. Retake or exemption? Okay. Yeah, guys, if you have A's or A minuses all 4 quarters, then you don't have to take the final. Then you'll just have to come that day and you do like a little activity thing. It's nothing major. When that first started, they had all these like huge projects they were going to have you guys do, and I was like, I don't understand how that's like a reward for doing well all year, so I will make it pleasant.
So if you take the finals, does it count towards your grade?
It's 10% of your grade, yes.
It has to be, even if you have like an A.
So you have A's all 4 quarters if you're still taking it, or you don't have that, but your average is an A, then yes, it counts.
I was asking.
Are we gonna review a lot?
Not a lot, because I'll teach you Unit 8, Unit 9, Unit 10. So it'll be like the Unit 10 test, then it'll be review for the retake, review for the final. Like it's pretty stretched at the end. It's a lot of like testing and reviewing at the end, so. But not as early as in a lot of your other classes. Like I get to just keep teaching you guys, because there's no SOL, no AP exams. So. That's really good.
How bad is the
Is the what?
How bad is it? Like, seems like in the grade out a lot.
The final?
Yeah.
No. It's 10% of your grade, so that's not huge to begin with, and most people tend to score relatively close to what their average is. So it's pretty representative. Final is all multiple choice.
Oh,
Good for you, good for me.
How do you do half the stuff?
Yeah, it's interesting.
Right.
Like 50. Yeah, right around 50.
Is it one class?
That's me in English.
Final exam?
One class period?
It's like a slow.
You guys are really stressing about the end of the year. Yeah. You want me to put that on Blackboard early? Yeah, so you can, you have time to start earlier.
Actually, no, there's like 3.
Okay, back to what we're currently working on, guys. So this one, did you stop here or did you reduce?
I stopped.
Wait.
I attempted to.
You should stop here.
Yes.
Oh,
Okay.
yeah.
You can't reduce pieces. Guys, let me give you an example with numbers, why this doesn't work. Like, let's say I had, I don't know, 3 plus 8 over 4 plus 5. You guys get that that's 11 over 9, right?
Yeah.
With what you guys were trying to do, it would be 5 over 5, which is 1. Is that right? Or you could have turned that into 1, I don't know, and made it 5 over 6, maybe? Either way, not the same as 11 over 9, right?
Yeah.
Okay, so don't do that. That's not okay.
That's why.
You can only reduce factors, not pieces, but factors.
You give us a fact, or not a fact, but like a factor example. What you were just talking
Yeah, so like, let's say, do you want numbers or variables?
about. There.
So a
Okay.
mole is
We can do. So I can take a 2 out of the numerator. This is reducing. So I could do that.
Because that's equal to.
This is the same as x minus 2x plus 2. So I can't cross out any of the other factors. Okay? If it had been
X squared plus 4.
like something like that, then you could do that, and you could do that, and you'd have a 1. Okay, you with me? Okay. All right, back to this. It's weird. Pretty sure there used to be lines on this page. Yeah, right. I'm telling you, this file, there's something weird going on with it, and the like box thing I made is gone. That's okay. You guys see it, right?
Where'd you put it? What do you know?
Surprise.
Okay. Okay. We're gonna do some domain and range here, guys.
Oh, really?
Okay, guys. You're gonna find domain and range for each of these things, these items here.
Do you now like understand like
What in the world is happening? Pretty sure I'm like not gonna be able to move right either.
I was mistaken.
All right, guys, jot it down. We've got this little relation here: 6,3, 10,5, 6,2. Got it, David? Do you need him to sit in the front?
You gotta, I can read out one of the things I can transcribe.
So helpful.
You read it backwards and sideways.
Not so helpful.
Is this for the same one? Is it for you there?
Nope, totally new thing. Find the domain and range of this relation, and then decide is the relation a function. And then there is your relation. Okay, so totally new stuff.
Are we trying to do this, or are we just talking about?
No, try to do it. I think you guys remember how to do it.
No.
No? Oh, we don't remember this? Okay. Oh.
Just like, I'm not good at math unless you teach me. I don't know. I can not for you.
That's definitely
It's a lot of pressure.
That is a lot.
All right, domain. Yes, you have to use these little squiggly brackets, okay? These are just 3 points, like 3 ordered pairs. If you graphed it, you'd have 3 dots, you know? Okay, that's all that is. So domain, is that your X or your Y?
That is your efforts.
Okay, I see a 6, a 10, and a 6. You don't list the 6 twice, you just tell me the domain is 6 and 10.
Oh wait, isn't it like the Y value piece?
Close.
Or the
The X went up. Okay. I don't care what order you write it in, just make sure it's all there. What is the range of this relation? 3, 5, 2. Okay, here we go. No, I do not care. Some people like to actually put it in numerical order, that's fine. Just as long as you cover all of them and don't repeat any values. All right, so is it a function or not?
no.
No, why?
We repeat that.
Yes, the X repeats, so. Function, no, X values repeat.
And a function is like the vertical line test.
Yes, if you're looking at a graph, yes.
This is harder to get.
No, we'll do more. I think the hardest part from today is domain algebraically. What's nice this year is we've already done that once, so I think you're going to do better than classes have done in the past. 1, because we cut the unit in half, and 2, because you've already seen it. So, and it was this year, so I taught it to you, so you should know it. Okay, right there.
I can't wait till I go to one of your spring classes and get Tom Sweet's paper chart. It's gonna be fun.
Interesting. So for it to be a function, it's just that function. For it to be a
How
function,
you're
like
like,
a function.
Yes.
So it's gonna tell you to go fast, I know you have to make graph probably for the log.
I'll just give you like trig quiz values, and if you don't get them right, you have to add resistance. Yeah. Okay, so domain. That kind of domain where you just list the x and y's, that's simple. You've been doing that for a long time. What we're going to add to it is finding domain algebraically. So when you look at an expression, what you have to think about is, do you have a fraction? Do you have an even root? Because we know we cannot divide by 0, and we cannot take the square root or even root of a negative number. Okay, so go ahead and jot down these ideas here, and then you can write down 6 and 7 if you want. But we'll go through them together. So what happens if you take the square root of a negative? Yes.
What do we do, I?
Not with this, but eventually.
The i's are full.
That's okay. Yeah, that's fine. Just don't talk to them. What does what? Oh, even? So square root, you know, has no number in the index. 4th root, 6th root, 8th root, those all you cannot take of a negative number. But like cubed root, that's fine. Cubed root of -8 is -2. Okay? So any of the even roots. All right, then again, jot down 6 and 7, and I'll walk you through those. You see this, right? I'm trying to erase. Nothing is happening. Okay. Let me try closing and reopening this because you see it, right? Okay, we're gonna do this. Maybe we're doing nothing, guys. Look at this. I call that the spiral of death that just spins around. It means your file's dying. All right, well, we'll talk about 6, and then I'll move things again for you. So we have a fraction in that one, right? Just wait. We'll record again. All right, guys. So the first one here. What? I feel like I waited an adequate amount of time, guys. Okay, so you need to ask yourself every time, do I have a fraction? Do I have an even radical? Okay? I have a fraction this time, right? So all I need to worry about is that denominator. That's all we care about right here. And the issue is I don't want my denominator to be 0. Okay? So that means x cannot equal -3. So when I'm writing the domain, there's 2 ways I can write it. I waited, Fletcher. As long as I can. All right, remember this notation? X such that x is an element of the reals?
No.
And then x cannot equal -3. That is called set notation. The other type is called interval notation. And if we're saying every number except -3, that would be -infinity to -3 with a parenthesis.
We have with set.
Write both right now just so you have that notation. You need to be aware of both. I could give you multiple choice question where I only write it in one form or the other, and you want to make sure you know both forms, okay? That is called interval notation.
So it doesn't equal. What do we have?
So the one value of x that will not work for this function is -3. So that's the one value that's not a part of your domain.
Do you have bracketing?
Well, if you bracket the -3, then you'd be, yeah. No, because infinity is not a defined value, so you can't put a hard bracket on it. You okay with that one? Okay, so number 7, I have a fraction again, right? So what do I care about? The denominator, so 2x minus 4 cannot equal 0. So guys, what can x not equal? 2. So my domain, I could say x such that x is an element of the reals, but x cannot equal 2. Or I could say -infinity to 2. 2 to infinity. How do we feel about that? Kind of okay? Alright, let's jot down 2 more. So number 8, f of x equals square root of x plus 4. Number 9, f of x equals 2x over the square root of x minus 5. So again, we're finding domain with these. So jot them down and I'll walk you through them.
How do you call a runner for classes?
If you don't have a class a certain period, you can talk to like attendance office or guidance office to be their runner. Or you can be a TA.
Can I leave this class now? Well, if I just ask the counselor if I can quit this class. Do I just get failure?
You probably have a withdrawal pass at this point, but I don't know why you would do that.
Because he secretly doesn't make me
That's probably
It's like,
Fine, you
you're
don't have to
amazing.
like me.
You're like top 3. It's top 3. Oh, she's top 2. I mean, you and Mr. Max are pretty up there.
I'll be sure to tell him that. All right, let's think about our radical here. What can I not take the square root of?
0.
No, I can't take square root of 0.
Negative.
Negative numbers, okay? So what is under the radical, the x plus 4? I want it to be greater than or equal to 0. That whole quantity needs to remain non-negative, okay? Because I don't want you to memorize this stuff. I want you to be able to think about it and understand it. Does that make sense? You don't want negative numbers, so it must be greater than or equal to 0. Okay? So then I just solved the inequality. So x must be greater than or equal to negative 4. That's it. For domain, you're just going to say x such that x is an element of the reals. This must be greater than or equal to negative 4. Or interval notation, how would I say that? Not negative infinity to negative 4. Yeah, or what? Yes, negative 4 to infinity. Because I want everything bigger than negative 4. Okay? So those are the 2 ways you could write that domain. We're not always going to write 2 ways, but just so you get to practice it both right now. Okay with number 8? All right. Number 9. What's going on here? What do I have? Yeah, I've got everything. I've got a fraction and I've got a square root, okay? So again, what I care about is this denominator. So that x minus 5. Now last time I said greater than or equal to 0. What do you think I'm going to say this time? Just greater than, yes. Okay, why? You're right. Right, it can't equal 0. It's the denominator. We do not want it to equal 0, so I'm not going to include that. All right, so then when I solve that, I get x is greater than 5. My domain, squiggly bracket, x such that it's an element of the reals. This is greater than 5. Or interval notation, what would it be? Right, so it'd be parenthesis 5 to infinity, okay? So far, so good? You don't have too much left for notes. All right, 10 f of x equals the square root of x squared minus 4. 11 x equals square root squared minus 2x. I'll give you a minute to write those down. All right, these require the most work. We only have one more example after these two. Okay, guys, what I want you to ask yourself every time you start one of these problems. 2 questions. What are they? Is it a fraction?
Is it an even square root?
No. And is it an even square root?
Yes.
Okay, so we do have something to do here. Again, I start with what's under the radical. What do you think? What am I going to say? Greater than or equal to. Good. What did you say, sorry? Do I have a fraction? Do I have an even root? Because guys, if the answer is no to both of those, you don't have any work to do. There's no restrictions on your domain. Negative infinity to infinity, all real numbers.
You would, what if I did test,
You would just say x such that x is known in the reals.
okay.
Aren't you not allowed to like square root negative?
This, so like if it's.
Okay. So, point. Let's look at this. Do you think this is the same as that? Or, I don't know, that? No? Okay. Let's think if I had 9 minus 4. That's square root of 5, right? Is that the same? No. So square roots, you can't take square roots of individual terms. Again, it's whole factors. Okay, so just a simplifying point on that one.
But only square root is
The only square
x.
root
Would be x
is
squared
x.
minus 2.
So you think you can take the square root of just the 4?
No, but I don't think it takes. I'm
Let her explain, let her explain.
I'm really overthinking this.
You are overthinking it. Okay. We're going to go back to something you've already done this year. To solve this, you have to factor. So what does x squared minus 4 factor into?
X plus 2.
Okay, good.
That's what I was thinking of.
Oh, okay. That's where you were going. All right. Then I'm going to make a number line. You guys remember this with the little pluses and minuses from earlier in the year? Like when we did polynomials, all that stuff?
Wait.
Ew, okay. Well, maybe it'll be less ew this time. I don't know. School time. It's much better the second time you go through it, though, than the first time you're learning it. All right, so what do you think the two values on my number line are going to be?
2 is negative 2.
Okay, and remember, put them in order, so negative 2 would come first. There's 2. Okay, I'm going to do it over here just to make sure you guys remember what exactly it is that we're doing. Remember, we have to test regions. What's the easiest thing to plug in? 0. 0's in here, right? So this is the region I'm testing. I put the zeros in here. Okay, so what is 0 plus 2? Positive. What is 0 minus 2? All right, positive times a negative? Negative, okay.
Plus negative.
Right, will it alternate?
Yes.
Yes, when doesn't it alternate? Yeah, if this had been like x plus 2 quantities, quantity squared, then you're going to have issues with the alternating. But because none of our factors have any multiplicity, you guys remember that with like bouncing off the x-axis with our graphs, all that stuff? That's all still a thing. Okay.
This is all of it.
Well,
They're
this
like
is
the
day 1 of
multiplicity.
the unit, yes.
This-
I'm not going to make you graph this. You just have to understand what the number line is telling you. If you don't like thinking about whether or not it alternates, you can always plug in numbers in each section.
I just need more reps.
I just don't want to do that. So do we agree with that? Yes? Okay. You can kind of read what I have up there. So I then need to ask myself, okay, what am I trying to answer here? I want to know when it's greater than or equal to 0. So do I want the positive part or the negative part? Positive. I want over here. I want over here.
We do that.
Do you ever include it?
What do you think? Do we include the negative 2 and 2?
No. Yes, yes, we do.
Because it says greater than or equal to, that means you're going to include it. Okay? So my final answer here, and I'm only going to do it in interval notation because that's so much easier to get from the number line.
True that.
Negative infinity to negative 2 with a bracket, union, bracket, 2 to infinity.
Well, still in the middle.
You show us that one though, if you can make us.
I will definitely show you the other one. Ben, what?
Okay, just keep going. I was asking a lot of questions that you probably would answer.
Well, no, you can ask me something about that.
Well, Well, what would you write over the denominator?
You would just do like -2 to 2. Yeah, if that was even part. Okay. All right. You want to do 11 together?
Yeah.
Yes.
Just like what we did earlier.
Yes. Yes.
So is there going to be a quiz later? Or
You guys don't have any, I don't think you have any real quizzes this unit. I think you have a quiz and a test, and that's it. Oh, twist? I thought you said quiz. No. That's why I was saying it's so much easier because you've seen it before. In the past, we've taught this unit
yeah,
first.
so why do you relearn it?
Well, okay. If I had just thrown it at you, would you have been like, oh, I totally know how to do domain of that?
Well, but
No, it's like,
why
why do we do it again if you already learned it?
like
Because you don't remember how to do it.
the same unit? Why are we doing the same unit twice?
It's not the same unit. That one was all about graphing a polynomial, right? Whether it was like above or below the x-axis. This is finding the domain of your function, which has to do with positives and negatives based on a square root. It's not graphing the polynomial the way it was before. Because remember what you did before, you'd have like, oh, we'll do a little one here. You'd say, okay, that's going to cross at 3, at -4, odd degrees, the ends are opposite. It's going to bounce here. This one is inflection. I could find my y-intercept, and there's my graph. Okay? What you're doing right now, what did we just have? Square root of like x squared minus 4? Is that what it was? If we were to graph this, we want to know when are the values under here greater than 0, greater than or equal to 0, and that's because the actual graph of this equation looks like this. So you're just telling me the domain, like the x values that actually work. It has nothing to do with it necessarily being above or below the x-axis. It's like, what values can you even plug in? Whereas that, like the domain was all real numbers. So it's the same technique to tell you a different piece. Okay? Is that what you're asking me?
Yeah.
Okay. But you should be better at it, in theory, right? Okay, so let's look at 11. No fraction, but I have a square root, so I take what's under there. Say it's got to be greater than or equal to 0, right? No fraction, so it can equal 0. What do I do next? Okay, so I take out an x. What goes on my number line? 0 and 2, good. Okay, I can't test 0 this time because it is one of my points. So what do you want to test? 1? Okay, so 1 would be right in here. 1 is 1, that's positive, okay? And what about 1 minus 2? Okay, so positive, negative, so overall negative. Will it alternate? Yes. Which I want the positive, right? Are the 0 and 2 included?
Not the 0.
Why was the 0 not?
I just know that.
You just don't like zeros?
No, I know that you said it earlier. I just can't.
If we're dividing, we would not include them, like if this was the denominator of our fraction, but we don't have a fraction, so. Okay. So negative infinity to 0, and 2, 2, 3. Okay?
So what do you not include?
Let's say we had the problem and it was like 3 over square root of x squared minus 2x. Okay, so exact same thing under the square root, but it's in the denominator of a fraction. So my very first step, I would have said x squared minus 2x has to be just greater than 0 instead of greater than or equal to. So the difference, you include it on these, okay? You don't include it because it doesn't have the or equal to. We don't want it to be 0 because it's the denominator.
Oh, yeah, just when it's denominator, it's going to be on the bottom.
Right. Yes. That's what I want you to do, is think about that so you understand what you're doing. If you try to memorize each different little scenario, you're going to lose your mind. I do not want you to lose your mind, okay? All right, one more. That one wasn't real. I know this is in a weird... All right, let's say f of x equals 3x cubed minus 2x squared plus 5x.
It's just like
So, please do not immediately start factoring on a problem like that, okay? That's why I'm saying ask yourself those two questions every problem. Is there a fraction? No. Is there an even root? No. Is there a square root going on in that problem? Riley, you look perplexed right now.
I got for second I got like square root and just square. But now I get it.
You see it? So if there's no root and no fraction, you do not have any work to do. It's just negative infinity to infinity. Okay? Okay, we're going to do whiteboard practice.
Whiteboard.
Right. Well, it was the same as 11. Just I put that. That is the same as that.
Okay.
Being in the denominator, fraction just changes it to greater than 0 instead of greater than or equal to 0. Okay. All right, guys. So find your whiteboard, find a marker. There's definitely enough to go around.
Wow, grabber. That was really good. That's me in English every morning. I still have all of my like stuff. I know.
Oh, it's good.
It's
something that goes on.
That's so weird. Like, I know. Yes. Anyway, you're not saying that. I was like, hey. Yeah, I should have new words instead of these good things. I know. Or I like start to lose words.
All right, guys. So first one here, I want you to tell me the domain. Once you think you've got it, hold it up for me. Take that.
Yeah.
You're gonna scoot your desk back. Yeah. Close, but not quite. Think about what you're doing. The inequality we wrote is wrong. Talk to each other if you need to. This is not stare at your phone time.
Oh, I got one.
No. I can't see your Okay.
Wait,
Is your domain actually written somewhere?
yeah, almost. Wait, do you have to do the line thing? No, you don't.
No.
Don't you get 2 as the one that I can't equal?
You get two things that can't equal. No. And then think how you write that.
Oh, it's 2 and -2.
No.
Is it
This
what's
is a struggle. This is why
Wait, is it this one?
you're overthinking. But you're close. No.
Like line.
No.
What do you think? Is there radical going on? No number line. Guys, the only time you need the number line is if it's a square root. No, because we have a fraction. Keep trying. There's a square root. A square root and an x squared or higher under that. Okay. Oh, you said it on paper. Close, but not quite. A lot of people are coming up with that answer. Okay, yes, for set notation, yes. Yes, do you see how it's different?
Yeah.
Okay.
Keep on go.
No. What's interesting is I think a lot of you are thinking the right thing, but you just aren't writing it right in integral notation. I think so.
Can I do set?
Just find the domain. Close. No, not right. All right, let's talk about this one. Okay. We don't actually need this. Okay, I'm gonna talk to you, just hold on. All right, guys, so it's a fraction, right? So what do I care about? Yes. This denominator cannot equal 0, so I start here. Okay, it's x squared minus 4, so I can go ahead and factor that. So there are two things that x cannot equal. A lot of you had this and then just didn't have the actual domain written correctly. So you're getting to this, but then you don't know what to do with that. Are we okay with the whole idea that these are the two values that would cause your denominator to be 0?
Yes.
Okay. If you think about what that means, it means every single number except for 2 and -2. So that's negative infinity to -2. This is the part most of you forgot. It's the numbers in between, right? Those are okay. And then it's the numbers after 2. So if you have x cannot equal certain numbers, you're just jumping over those numbers when you write out the whole interval. Okay? Then
We keep our answer set notation.
you could have done set notation. You could have said x such that x is an element of the reals, that x cannot equal 2 and -2. Again, be aware of both notations, because what if it's multiple choice and this is what I give you? Okay? Questions on what?
Wouldn't give us both.
No. Does it make sense now that you see it? Yes? Okay. You can copy it down. Good job. Oh, okay. All right, let's try this guy.
Nope.
Yep.
So I guess after school.
Basically, why do you give us the top thing if we're not making it?
What do you want me to give you? A fraction with just an empty numerator?
Yeah.
One. I mean, if it's just a one, it'd be like, okay.
So there could come a point when I put like a radical in the numerator and something else in the denominator. You do have to think about both. Those are tricky though.
And you're not gonna do that to us.
We'll see. Probably not today. Close. We're both close. There's plenty more. You can just grab another box right there. Yes. Not quite.
Almost.
Not quite. Not quite.
Which notation?
I would do interval on this one, I think it's easier. Yes. Good. Do you understand why that's different? Because if you actually plug those in, it would equal 0 in your denominator, so you don't want to. Yes. Yes. Let's say 0.
Yeah, 0 to.
No. Not quite.
Tomorrow, will I do at this stage of a meeting that scale like that? I get it wrong so many times.
All right, guys, let's look at it. So first, when you look at this type of problem, do you recognize that this requires a number line? You guys, can you tell me why you or when you need a number line? Okay, when you have a radical and some factoring required. So if you have x squared or higher degree under an even root, you have to do a number line. If it had just been x minus 4 under the square root, no number line required. Okay? All right, but this did require a number line. You have brackets. Do you get y parentheses instead? Okay. So guys, it all comes from this very first step here. You need to say greater than 0, not greater than or equal to 0, because it's in the denominator. All right? You go through your factoring, number line testing. The negative 2 and 2 are not included. So that's why it's negative infinity to negative 2 with a parenthesis, 2 to infinity. So let's plug like negative 10 in here. What's negative 10 squared? You see it? Okay. That's the whole point of testing the number line, is so you can find the positive regions of the number line, because that's what will give you positives under your square root. Okay?
You could test that by like, probably using way to do like the plug-in for.
Well, I would plug in 0
Oh.
in here, which gives me the negative, and then I know, since there's no multiplicity, I know it's going to alternate. And so then this is what, if you don't trust that, you could plug in 3 or negative 3, whatever you want to do. Okay? All right, let's try again.
Sounds like the same thing, basically.
What's the same thing?
Like, it's the same thing if you have a square root or not.
It's without the two things thing, all right?
Well, but that's totally different.
Yeah, but then why do you have to draw the number line then?
So
Like, what's the point of drawing a line if, like, you
it's
know-
not always going to be the two ends of your number line.
Oh.
Okay, is that what you're talking about?
Yeah.
Okay, yeah, good. Good, good, good. So we're doing this thing called whiteboards, Finn.
You know what? Take his 4 points. Give it to me.
Good.
Give me the 96.
They put an eraser.
All right, guys, you should definitely be done with this one, but I am not seeing very many boards. Yes. Okay. I'm ready. Yes. Okay. It is, guys. All right. Again, ask yourself, do I have a fraction? No. Do I have an even root? No.
I'm so confused over the even.
Okay, so square root,
What happens if you write the hard brackets on?
infinities. I will take points away
Well,
from
yeah,
you.
but it's infinity to infinity.
Yeah, we can't include them, they don't have
You
values.
can't include it.
It doesn't end, so you can't like stop there because it doesn't end.
Never stop.
Okay, or like 4th root, 6th root, Those are even roots. Not an even exponent, but the actual like radicals. Yeah. Kind of. All right, so that one we're good on. All right, try that one. Sorry, I had to think through that one in my head. That's what it says, yeah.
Okay.
This one's a little different.
Would you like next?
Okay, it's a radical, not just a fraction. So you're not going to say not equal to. You're going to have just greater than 0. No. No. It's a little tricky because you got some negatives going on in there too. Still no. Now, if there wasn't a square root and it was just a fraction, you'd be right. That is called a square root. Good.
Radical sometimes.
Radical. Just a fruit. Yes. I like how you're like smiling. Like, please. A little bit.
Would it be greater than? No, just greater than.
Yeah.
Don't do that.
I don't think square consciousness. Wait. Whatever she was.
Yes.
She was thought she was.
Yay. That's the goal. For you to see. All right, guys. Do we need to go through it, or does anybody else want to show?
Can you show the answers so if I gotta write it down?
You're done forever? So that's accurate. All right. So fraction and radical. So we start with greater than 0. Okay? There is no x squared. There is no number line required. Okay? You just solve. The tricky part here is, remember guys, dividing by a negative flips your sign. Okay?
Wait, so when do you keep it short?
You keep it short.
Like down through the full interval?
You mean the number line or like only one of these?
Only one of them.
Well, it depends on the problem, but usually if what's under the radical is not a square, x squared or higher. Okay. If you have a radical and x squared or higher. Yes, yes, yes. Because this, like if you factor it, you're not going to have two things that make it 0. So there's like one, so you can do a number line, and it'll be 1 point, and then it'll be at 2, and you'll, you know, I mean, so you could do that, but it's not necessary. Okay. Do we understand it now? How many of you guys forgot the whole flipping it with a negative?
No.
Yeah, okay.
Nope.
Nope. All right. Let's try that.
This looks like a really long one.
Guys, will this one require a number line?
No, it's all real.
No, it is not all real numbers, but it does not require a number line, okay? You do need to factor, but no number line. So, it always has to do with the radical. If it's in the denominator of a fraction, do we want it to equal 0? You gotta find the 2 answers. Yeah, so those would just be less than. If it's just a radical without any fraction, it's greater than, not less than. So like this one, We'll go all the way. Apparently I haven't given you any that were greater than or equal to. If this had not been here, and it wasn't a fraction, this first step would be greater than or equal to. But it's in the denominator, we do not want it to equal 0. Sorry, I moved things forward.
Yeah, why would you use the number line 301?
Yes. Is it x squared? Like, is there factoring where you're going to get multiple things to make it 0?
So I guess it's gotta be yes.
Yes, yes. Yes, yes. Nice, nice. Good. Alex, Kevin, how you guys doing back there? Do you have an answer? Okay, good start. We're on number 5. Do you know that? Okay. Just checking.
The 36 is on
Ah, it's feedback. It's negative 6 times 1. Okay. Yep. All right, guys, let's look at this one.
I feel like it doesn't kind of sound like even like the vacation was it
All right, guys, so a lot of you wrote it in the set notation. That's completely fine. Yes, that is correct. This is what it looks like in interval notation. Again, do you see the difference why I'm doing this inequality sign?
Yep.
Okay. All right, homework. In your packet. In your homework packet, you got 2 packets.
Like, you would it still be like a so complicated?
All right, guys. There are a lot of problems on the back, so let's just do evens on the whole thing, okay? So you won't have quite so many. Front and back evens.